Namaskar students, in today's video we shall derive the solution formula for a first order linear ordinary differential equation. So let us start today's video. My dear students, any linear ordinary differential equation of first order looks like this: dy dx plus some function of x into y equal to another function of x. Over here I have written dy dx plus px into y equal to qx. Now the question is how to solve this form of a linear ODE of first order. See, we shall use the knowledge of the previous chapter, exact differential equations, and that integrating factor part to solve this differential equation. And we shall deduce a generalized formula which can be used to solve any linear ODE of first order if it can be transferred into this form. So let us see how are we deriving that formula. See, from our knowledge of the exact ODE chapter, we have seen that if an ODE is written in this form, m dx plus n dy equal to 0, where obviously m and n are functions of x and y, and if we can find derivative of m with respect to y is equal to derivative of n with respect to x, then we can conclude that this ODE is exact. So our first motive is to test whether this form of linear ODE is exact or not. For this, we have to transfer this form into this form. See, this is called the differential form, and this is called the derivative form because the derivative is present over here. So let us transfer this derivative form of a linear ODE into a differential form of the linear ODE. It's very simple. See, we can write this one as dy plus px y dx equal to qx dx, or px y minus qx. For our simplicity, let us just write p and q. P means a function of x and q means a function of x. So p y minus q dx plus dy equal to 0. Now see, it's very evident that this has been transferred into this form. Now if you compare these two forms, what is m? See, m is that part which is dx. Over here with dx you have py minus q, so m is py minus q, and what is n? N is that part which is dy. Over here with dy, what you have? With dy you have nothing. Nothing means you have 1. So n is 1. Okay. So we have m equal to py minus q and n equal to 1. Now we have to test whether this is exact or not. For this, we have to find the derivative of m with respect to y and derivative of n with respect to x. So over here, derivative of m with respect to y, what is it? See, with respect to y, what you have? P is a function of x, that you have y, so it is p minus, now q is a function of x, with respect to y the derivative is 0, so over here you have only p. So del m del y is only p. What is del n del x? Del n del x is 0 because this was a constant. See, basic differentiation, basic derivative finding, that you have to know. If you have forgotten that, then please go to some books of HS level, see the formulas of derivative, practice those, and then come back and see this video. For the time being, now it is clear that del m del y and del n del x are not equal. If these two would have been equal, then we could have said that this given ODE is exact. But now the situation is, since del m del y and del n del x are not equal, okay, we have to find a integrating factor. So we have to find an integrating factor which we have to multiply with this and then again try to solve this equation. So let us find out that integrating factor. Now see, if you have forgotten that exact equation part and integrating factor part, I'll give the link in this description box, in the video description box of this video, where I have a dedicated video for exact equations and integrating factors. You can see that video and then again come back to this video. So let us see now how to find out the integrating factor which will help us in solving this equation. See, we had a rule that if these two are not equal, and anyhow if we can find that 1 by n del m del y minus del n del x equal to some function of x only, then the integrating factor is e to the power integration of this function. Okay, let us see whether this rule fits in over here or not. See, if we apply this rule over here, what we have? 1 by n del m del y minus del n del x. What is 1 by n? 1 by 1 del m del y. What was del m del y? Del m del y was p only. And what was del n del x? 0. So p minus 0, that is p only. Now what is p? P is a function of x only. So you can apply this rule, because this rule says that if this expression is a function of x only, means it will not have any y part, then the integrating factor is e to the power integration of this function of x. Over here we have seen that 1 by n del m del y minus del n del x is a function of x only. P is a function of x only, there is no y part. So according to this rule, the integrating factor for this problem is e to the power integration px dx, or simply we will write e to the power integration p dx. Now the work is to multiply this integrating factor into this equation and convert this equation from a non-exact ODE to an exact ODE. Thus let us multiply both sides with the integrating factor, e to the power integration p dx, e to the power integration p dx. Now if we multiply this one, the next line is e to the power integration p dx dy dx plus e to the power integration p dx into p into y equal to e to the power integration p dx into q. Okay, now let us see one thing. For the time being, keep this one aside. Look over here. See, if I do derivative of, that is ddx of y e to the power integration p dx, what is the outcome then? See that u into v formula, ddx of u into v means, what was the formula? ddx of u into v. Over here this is u, this is v. Y into e to the power integration p dx means u into v. So the formula was u derivative of v plus v derivative of u. Same thing we apply over here. So y into derivative of the v part e to the power integration p dx plus e to the power integration p dx into ddx of y. Okay, which is equal to y. See, derivative of e to the power something is that only. So it is e to the power integration p dx into again a derivative of this part, that is ddx of integration p dx plus this part e to the power integration p dx into ddx of y means dy dx, which is again equal to y e to the power integration p dx into now derivative of integration. See, derivative and integration both are anti to each other. So derivative of an integration both will cancel out seemingly and only p will remain, because derivative is anti-integration and integration is anti-derivative. So both will cancel out and only p will remain, plus e to the power integration p dx dy dx. What is this? See, this is nothing but the left hand side of this equation. So this is the LHS of this equation. See, y e to the power integration p dx into p, y e to the power integration p dx into p, plus e to the power integration p dx dy dx, e to the power integration p dx dy dx. So you can say this part is actually equal to this. So instead of this, let us write ddx of y e to the power integration p dx, because this is actually this and this is actually this. So instead of this, let us write this, which is equal to e to the power integration p dx into q, or this you can write d of y e to the power integration p dx equal to e to the power integration p dx into q dx. This dx will go that side, as if, even though it is not, the working procedure is not like that actually, but for the timing let us think in that way. Or now let us integrate this both sides. If we integrate both sides, see, integration of d of something is this. So or this is equal to y e to the power integration p dx equal to this integration e to the power integration p dx q dx plus an integrating constant for this happened integration. So this is actually the generalized solution for a linear ODE of first order and first degree. See, a linear ODE of first order and first degree actually looks like this form. So the solution will be this. So whenever any linear ODE you will find which is given to you for solution, you will have to just find and extract the p and q from that. Just find the p and q and then put that p and q into this formula. Integrate it, solve it, you will get the solution of the original linear ODE of first order. My dear students, if you have understood the solution procedure of a linear ODE of first order in today's video, do like this video, share this video with your friends, follow my page and don't forget to subscribe to my channel. Till then, goodbye.